All right, let's finish off section 8.3 today. And what we're going to do is we're going to look at another pair of trig functions that we could multiply together and integrate. So in the previous video, we looked at products of sines and cosines, and now we're going to look at products of tangents and secants. I made a decision just with the time that we have left in the school year that we're not going to take a look at products of cotangents and cosecants, but just know that the process is very, very similar. We're going to have strategies depending on what the powers are. So just for future reference, know that at the college level in Calc 2, you'll probably look at products of cotangents and cosecants as well. Okay? But today we're going to deal with products of tangents and secants. And there's going to be three strategies that we can use. So I've split them into three cases. So you're going to need to put each one of these onto your note card. Case number one, what do we do if the secant power is even? What do we do if the secant power is a 2, 4, 6, 8, 10, 12? What do we do in a problem like that? Well, what we do is we split off a secant squared. So as an example, if it was secant to the sixth, we'd break off a secant squared and then write it as secant to the fourth times secant to the second. Okay? And then what we do is use the identity. Secant squared is equal to tangent squared plus 1. And hopefully you remember that this fella right here is one of our Pythagorean identities. And if you don't remember that, it's no big deal. Just look back on your trig sheet. Down the front side, on the front side, left-hand column, about a little over halfway down, maybe 2/3 of the way down your page, you'll see that identity. Okay? So let's go ahead and go through an example and show you how it works. And I'm not going to go very far because I just want to show you the basic idea. What we've got going on here is a secant power that is even. Now what the strategy says is what we want to do is break off a secant squared. So we leave the tangent alone. And I'm going to break secant to the fourth into secant squared, secant squared. Okay? Now, just kind of a heads up as to why we're doing that. We're going to break off a secant squared so that eventually we're going to make a u substitution. And what we're going to want is our du to match up to secant squared x dx. And you can probably imagine what the substitution is then going to be. I won't give it away right now, but I hope you can. So when you take the derivative, du is equal to secant squared of x dx. Okay? So first thing, split off a secant squared. Next, anywhere you see a secant squared, replace it with tangent squared plus 1. So we're going to replace, whoops, I forgot the x there. There we go. We're going to replace this secant squared with tangent squared plus 1. Not this secant squared, not the second one. We're going to leave the second one alone. We're going to leave this one alone, right? We want to keep that. But we want to write all of the other secants, if there are any, in terms of tangents. And now you'll lose the case there. But now we can do the work, which is fairly easy. Now we just have to use the distributive property. So tangent to the fourth times tangent to the second is tangent to the sixth. And tangent to the fourth times 1 is tangent to the fourth. And now u substitution works great, replacing the trig function raised to the power, tangent, with u. And now when we take the derivative of the substitution, the derivative of u is 1 du, and the derivative of tangent is secant squared of x dx. And there it is. That's why we did that. That's why we left the secant squared at the end. So now when I make my substitution, replacing tangent with u, I'll have u to the sixth plus u to the fourth, and then the secant squared x dx gets replaced with du. And of course now very, very, very simple to integrate. Just add 1, divide by the new, add 1, divide by the new, attach the constant of integration, and now just switch back to the variables we started in, replacing u with our substitution. So we could then write our answer as 1/7 tangent to the seventh plus 1/5 tangent to the fifth plus c. And that would then be our integral. Okay? So the first strategy, what do we do when the secant power is even? We break off a secant squared, right? And then replace the other secants with the identity tangent squared plus 1. Okay, so that's the first situation that we have. Our second situation, let me make this a bit bigger so you can see it a little better. Our second case is, what do you do if the tangent power is odd? What do you do if the tangent power is odd? As an example here, you can see that the tangent power there is a 5. What we're going to do this time is split off a secant tangent and then use the same identity, just in a different version. Instead of having secant squared is equal to tangent squared plus 1, we essentially just flip the plus 1 to the other side, and we're going to use tangent squared is equal to secant squared minus 1. Okay? So here's how it's going to go. Here's how it's going to go. What we're going to do is we're going to take our original problem, tangent to the fifth, secant to the third, and we're going to break off secant tangent. Well, if I factor out secant tangent, that means I'm going to have 4 tangents left and 2 secants left. And I'm going to purposely put those factors that we're breaking off in parentheses. So I'm going to take a secant and a tangent out of what I start with. So if I started with 5 tangents, I took 1 out, so I'm left with 4. I started with 3 secants, I took 1 out, I'm left with 2. And again, the reason I'm going to put those in parentheses is eventually this is going to become our du. That's going to become our du. All right, but the next thing we do is anywhere I see tangent squared, I replace that with secant squared minus 1. Well, I don't actually have tangent squared. Right now I've got tangent to the fourth. So I need to think of tangent to the fourth as being tangent squared squared. And it's just going to take me a little while to write down all of the other terms. There we go. And now use the identity. Let me just scooch up the page just a little bit so you can still see it. Now I'm going to replace the tangent. Again, I'll write all this other stuff out as quick as I can. Okay, and now I'm going to replace the tangent squared with what it's equal to. So I'm going to replace that tangent squared with secant squared minus 1. And I hope you can see what's going on now. Let me choose red. Everything other than what's in parentheses, everything else is in terms of secants. So after I simplify, which is going to take me 2 steps, but after I simplify, then I'm going to be able to make the u substitution for secant. And again, I hope you can see that then this du dx equation is going to match up really, really nice. But I've got to do the simplifying first. I've got to square the binomial. So I've got to square the binomial, so that's going to be the first term squared. Secant squared squared is secant to the fourth. The first term times the second term times 2. So secant squared times -1 times 2 is -2 secant squared. And then the second term squared. -1 times -1 is +1. All right, and then again, just writing out all of these other terms. And then the second simplifying step I've got to take is I've got to distribute the secant squared. Again, leaving the secant tangent in parentheses. So secant squared times secant to the fourth is secant to the sixth. Secant squared times -2 secant squared is -2 secant to the fourth. And secant squared times 1 is secant squared. Right? Looks like a horrible mess. But now, if we replace the trig function that's raised to all the different powers, secant, with u, remember we have to take the derivative of the substitutions. The derivative of u is 1 du, and the derivative of secant is secant times tangent dx. And again, hopefully you can see that's why we did all of that. So now when we make our substitution, instead of secant to the sixth, u to the sixth, instead of -2 secant to the fourth, -2 u to the fourth, and instead of secant squared, u squared. Then we get to replace secant tangent dx with du. And now the integration is very simple. we just use power rule, so add 1, divide by the new, add 1, divide by the new, add 1, divide by the new, add the constant of integration, and then get back to the variables we started with by replacing u with secant. So this would then become 1/7 secant to the 7th minus 2/5 secant to the 5th plus 1/3 secant to the 3rd plus c. Okay? Alrighty. So that's the second strategy, is when the tangent power is odd. When the tangent power is odd. Okay? And there's one more possibility. Okay, the first two again. Secant power is even. Tangent power is odd. Or there's one last situation, and that is if both the tangent power is even and the secant power is odd. Both of these things are true at the same time. Okay? Then what we're going to do is we're going to rewrite the tangent power as tangent squareds. All right, so depending on how many you start with, we're going to rewrite those as tangent squared. So as an example, if you had tangent to the 6th, we would write it as tangent squared cubed. And then we replace tangent squared with secant squared minus 1. Then we use power reducing formulas. Okay? So let's run through our example. Since I'm starting off with the integral of tangent to the 4th secant, we take any tangents and rewrite them as tangent squareds, meaning we rewrite tangent to the 4th as tangent squared squared. Okay? Then, I'm just going to move up the screen just one little bit so you can see this next step. Then we'll replace tangent squared with what it's equal to. So we're going to replace tangent squared with secant squared minus 1. And now I hope you notice that the entire problem is in terms of secants. So with just a little bit of simplifying, I guess actually it'll take me 2 simplifying steps. I've got to square the binomial. So the first term squared, secant squared squared is secant to the 4th. The first term times the second term times 2. So secant squared times -1 times 2 is -2 secant squared. And then the second term squared, -1 times -1 is +1. Then if I use the distributive property, what I'll have then is secant times secant to the 4th, so that's secant to the 5th. Secant times -2 secant squared, so that's -2 secant cubed. And secant times 1, which is secant. Now, everything's just in terms of secants, So now what we're going to do is we're just going to think about breaking this up into 3 individual integrals. One, secant to the 5th. A second, -2 times the integral of secant to the 3rd. And the last one, the integral of secant. And then what I would want you guys to do, I'm not going to waste all of your time because we've already done this, but we would use power reducing formulas. We'd use the power reducing formulas to integrate secant to the 5th all by itself, secant to the 3rd all by itself, and secant to the 1st all by itself. And I'm not going to waste your time going through all of that. I've already shown you the power reducing formulas, but I'll show you the results, and then you guys could just choose to work on it yourself if you'd like to. Secant to the 5th is going to be 1/4 secant to the 3rd tangent plus 3/8 secant tangent minus 3/4 ln of secant plus tangent. Then the integral of secant to the 3rd is going to be 1/2 secant tangent minus the ln of secant plus tangent. And then the last one, the integral of secant is just simply the ln of secant plus tangent. Okay? And when you combine all of the like terms, I hope I did it okie dokie, you guys could double check me, but I believe we get 1/4 secant to the third times tangent minus 5/8 secant tangent plus 9/4 ln of secant plus tangent plus c. All right, I hope I did that okay. I was just bopping through it earlier this morning, so I hope I did the simplifying okay. But again, maybe I'll put this in red just to emphasize it. Right here, again, what we would do is use the power reducing formula for secant. All right, to go from the integral of secant to the fifth, to go from the integral of secant to the third, and I guess the last one is just one of our basic rules. Okay? So that's going to be the end of section 3 for us. Now you should be able to stop this video and finish off the rest of the assignment. Okay, let me know if you have questions. I'll continue to try and help you out using email or telephones like we've done in the past. So just give me a call or shoot me an email if you want some help. Otherwise, I hope everything's going okay, and have a little bit of fun on the quiz tomorrow. All right, see you later. Bye.